This Halloween, NASA will take you on a journey to the darkest corners of our universe, where invisible forces draw galaxies together as dark energy rips them apart. We'll travel to worlds with unimaginable conditions, perilous to humans, planets that rain glass. We'll hear sounds that flow eerily through the emptiness of space. Stop. Listen. Look up. And join us for a tour of our galaxy of horrors.
Happy Halloween and welcome to a very special hair-raising edition of NASA Science Live. I am your host, Scott Bednar. Okay, now this is a show all about you being able to interact with NASA scientists and getting your questions answered by them. It's easy. All you got to do is go on Facebook or Twitter and ask us a question using the hashtag AskNASA, or just leave a question in the comment box wherever you're watching this program today. So, it is the Halloweens, the Day of the Dead, and to celebrate this chilling holiday, we are taking you on a tour of our galaxy of horrors. First, we're going to start at the far reaches of the Milky Way galaxy and explore terrifying planets that orbit other stars. Then, we'll come a bit closer to home by exploring some of the more eerie environments in our own solar system. Have you ever heard radio waves from Saturn? Well, buckle up, you will today. Then, we will dive into the dark forces at play in our universe, dark energy and dark matter. What are you wearing today? Oh, me? Well, I'm just a mad scientist doing mad science all around the mad laboratory. Do you have a space or science-themed costume you want to share with us? Well, send us a picture using the hashtag NASA costume. We want to see them all. Now, I'm not the only one dressed up here today. The whole NASA Science Live crew is crawling with creepy costumes. Take a look.
Happy Halloween!
Positively ghastly. Okay, before we get knee-deep in some spooky science, we want you to help us determine the scariest image in our galaxy of horrors. We have 4 terrifying photos here, and we need you to help us vote on which is the most Halloween-horrific of them all. Okay, first up, we have a creepy coffin-shaped iceberg. After 18 years at sea, this casket entered a region in 2018 where Antarctic icebergs go to die. Ooh, spooky. Next, this frightening snapshot of an eerie skull asteroid. What's even creepier, in 2015, this cranium-shaped boulder flew by Earth on Halloween Day. Thirdly, we have this spicy image of our sizzling sun. These brighter and more active regions appear to be forming a jack-o'-lantern's face. Try covering that. And lastly, but certainly not leastly, this haunting portrait of the wretched Witch Head Nebula, screaming bloody murder into the nothingness of space. Okay. So we need you to tell us which is the scariest photo of them all. And it's really easy. All you got to do is go to Twitter, type in @NASA, and vote. We will let you know which is selected the absolute worst, which on Halloween Day means the absolute best, a little later in the show. Now, let's venture billions of miles past the boundary of our solar system, beyond Pluto and the influence of our sun, to learn about planets that orbit other stars, also known as exoplanets. And unlike our beautiful Earth, not all of them are very welcoming. Are you ready? Let's go take a look.
Lurking beyond our solar system, among the billions of stars and the exoplanets that orbit them, is another sort of Milky Way altogether. A place of unequaled terrors. Come with us now, if you dare, and discover the Galaxy of Horrors. Feel the rains of terror, the killer you never see coming. With winds of up to 5,400 miles per hour and torrential rains of glass blowing sideways, the weather here is deadly. And don't let its cobalt blue color fool you. This hazy, blowtorched atmosphere is riddled with silicate particles, making this an unearthly death trap no mortal would dare want to face. Or discover the zombie worlds that exist in this most inhospitable corner of the galaxy, the Poltergeist planet, one of 3 dead planets shambling through the twisted magnetic fields of their corpse star Lich. which is itself the collapsed core of an exploded star. But despite its demise, this undead star spins twin beams of radiation that could incinerate a spaceship foolish enough to venture too close. Even if you could make it to the surface, your nightmares would continue as the radiation from the zombie star rains down on planet Poltergeist, as well as her neighboring dead worlds of Draugr and Phobitor, creating sickly irradiated auroras to light up your certain death. These are just a sampling of the terrible, unwelcoming worlds that inhabit our Galaxy of Horrors.
Holy freaking free-holies. That was terrifying. Make sure to download your favorite Galaxy of Horrors posters today at a website near you, specifically exoplanets.nasa.gov. So, turns out you don't need to be a scientist or an engineer to work at NASA. Just look at me. Now, we are going to introduce you to the plagued minds behind these chilling works of dark art we just saw. Let's head on over to our friends on the West Coast at the Jet Propulsion Laboratory. Thalia, Tiffany, happy Halloween!
Scott, thank you.
Over to you.
So I am Thalia Rivera-Khan, and I am joined here by Dr. Tiffany Kataria, who is an exoplanet scientist. So Tiffany, we just saw the trailer.
Yeah.
Let's talk a little bit about the posters.
Absolutely.
So we have Reigns of Terror.
Uh-huh.
Can you tell us a little bit about this planet and what makes it so terrifying?
Yeah, and so this planet is called HD 189733b. It rolls off the tongue. It's what's called a hot Jupiter, and it's called that because it's Jupiter in size, but it orbits really, really close to its star. So it's actually 10 times closer than Mercury is to our sun. And so because of that, it's super, super hot. Hot enough, in fact, that the rocks we find on Earth are hot enough to be vaporized and forming clouds and raining out in the atmosphere. And because this planet also experiences very high winds, we'd actually expect this rain, these rains of glass, because they're mainly silicates, these sand source particles, we'd expect those particles to be driven sideways from the winds.
Wow, so our Santa Ana winds have nothing on this planet.
Absolutely not.
All right, so let's talk about our next poster, which is Zombie Worlds, PSRB 1257 plus 12. Can you tell us a little bit about these planets and what makes them so inhospitable?
Yeah, absolutely. So this system is actually perfect for Halloween because the names of the planets and the star in the system are actually undead creatures. So the star is called Leech, and then in the trailer you saw the planets are called Poltergeist, Draugr, and I'm forgetting the third one.
Phobitor.
Phobitor, thank you. And so all of those are undead creatures already, so it was prime for a Halloween poster. And so these planets are orbiting what's called a pulsar, and so this is a dead neutron star that's rapidly rotating. It's in fact rotating every 6 milliseconds or so, and it's really small but still really hot, giving off all of these radio emissions, and so in fact very inhospitable to life, but perfect for a Halloween poster.
Brilliant. So it was a pleasure working on you with
Absolutely,
these posters.
yeah.
I really enjoyed it. And it's amazing to see how important art is to science,
Yeah,
and,
for sure.
and explaining that science that can't always be explained very easily. So can you tell us, how has fun resources like these planet posters helped you and explain your science to the public?
Yeah, and so personally, I'm really passionate about both art and science, so it's a really awesome intersection of both of my interests. And so what I really love about these posters is that they're engaging not only to the general public, but also to astronomers, planetary scientists across the board, even people who are well into exoplanet science. And so it's really nice not only to point out the posters for their artistic elements, but also the science elements that are incorporated in these posters are almost like little Easter eggs for people to find. So, you know, the sizes of the planets, the particles in the sky, all of those things we can draw from in explaining not only the art, but also the science that goes into these particular systems.
Amazing. So we are going to take an Ask NASA question.
Okay.
So Zach Powers here asks, say a person on another planet, far, far away from another galaxy, took a clear picture of Earth.
Yes.
What time period would the picture of Earth be in?
Okay, well, Zach, that's a great question. That's actually something that we exoplanet scientists consider when we're looking at faraway systems, because light takes time to travel to us. And so, in fact, we're peering back in time when we're receiving light from a distant exoplanet system. And so, depending on where that other distant system that was looking at us was looking, they could be peering into different time periods of Earth, some glacial age or, present day when the Earth is really hospitable. And so, it could really look anyway, depending on what time they're peering into.
Amazing. So we have to ask, can you tell us a little bit about what is going on with your
Sure,
outfit?
yeah.
And how does it have to relate to exoplanets?
Absolutely. I'm glad you asked, Leah. So this wig here in my makeup represents a Terminator zone. And so I've got a really hot day side here on the right and a really cold night side on the left. And so I've tried to make the makeup coincident with that. And then, of course, always a good opportunity to wear a cat space shirt. But I did also want to ask you, Talia, about your costume.
Well, I am everything and anything. I am the universe. I have my planets here. I have my stars here, which only make up 5% of it, and the rest is dark energy and dark matter. So we're going to head back to the studio with you, Scott. Thank you so much.
Thank you both. So I understand there are billions and billions of planets, exoplanets in the known universe. What does this mean for your work schedules?
So, there are billions and billions of planets in the universe. What does that mean for our work schedules? Well, for me, it's a lot of trying to communicate all of those weird worlds out there. But for Tiffany, I think it's a lot different.
Yeah, never a dull moment.
Well, way to go. Happy Halloween to both of you. You look fantastic. Star-studded. All right.
Thank you so much, Scott.
Thanks.
Before we dive into the spooky mysteries of dark energy and dark matter, let's talk pumpkins. Working at NASA isn't all just science and math. It can be fun in games too. For instance, I'm not actually a Starfleet captain. NASA's Jet Propulsion Laboratory just yesterday hosted their annual employee pumpkin carving contest, and our friend Caitlin Soares has all the gaudy details. Caitlin, let's give him pumpkin to talk about.
Is everybody ready to go?
Our annual pumpkin carving contest is underway. Let's go watch these NASA engineers get their hands dirty.
Nice.
What are you guys carving today?
So we're carving the advanced deployable sutures, which is all of the deployable structures JPL's produced in the last 10 years plugged into a pumpkin.
Wow. What are you working on here today?
Oh, so we've got our rover that's on vacation to Olympus Mons. Olympus Mons is the largest volcano in the solar system.
My team did the Wizard of Oz theme, so we included the main feature is the lion, but we also included the scarecrow and the Tin Man.
So the Tin Man's a pumpkin. What is the scarecrow there?
It is a butternut squash. Just keep with the gourd family.
And we turned our pumpkin into the Apollo lunar lander. So we got the lander going down, and we also have real footage of the moon showing underneath it. Our jack-o'-lander landed safely.
Did you see those pumpkins? I can't even pick out a pumpkin without having a full-blown panic attack, let alone build a functioning amusement park out of one. Okay, let's pivot to darker matters. I am joined by two NASA scientists, Regina and Dominic. Thank you for being here today.
Thanks for having us.
I just want to first commend you on your costume wearing, looking wonderful.
Oh, thank you.
Okay, so I think a question that we should start with about dark matter and dark energy is, what is dark matter and dark energy?
It's an excellent question and a great place to start. So we'll start out by saying what we actually do know about dark matter. So we know, just like normal matter, like pumpkins and planets, that it interacts via gravity. And so this is actually how we first discovered dark matter and that it exists. Now there's about 5 times more dark matter out there than there is regular matter. However, one of the big differences between dark matter and regular matter is that dark matter doesn't interact with light or photons, so we can't see it, which is why we call it dark.
Now, dark energy, I can tell you what we know about it. What we really know is that about 2/3 of the total mass and energy in the universe is in the form of dark energy. And beyond that, we actually don't know very much. And Scott, the oldest and strongest fear is fear of the unknown. And one of the things we do know is that there are billions of dark matter particles flooding through your body at this very moment, and that dark energy suffuses everything around us, including ourselves and our own bodies. Thus far, they've been very benign, but they may change with time.
billions flooding through me right now. Thank goodness I can't feel them. Yeah.
Good thing.
So you're telling me that dark matter and dark energy is pretty much invisible or impossible to see. So how do we know it exists? How do you measure something you can't see?
So that's also a great question, and something that we're trying to do, to measure what dark matter is and where it is. And so one of the things we do is we have a theory as to what dark matter could be. So if dark matter is a weakly interacting massive particle, it could annihilate together in the universe, therefore forming other kinds of matter that we could actually observe, like photons. This is one of the ways that the Fermi Gamma Ray Observatory searches for dark matter.
Now, Scott, for dark energy, we mostly understand what it is by looking at how it affects everything else in the universe and the universe as a whole. Dark energy has a repulsive effect. It pushes everything away from everything else. It pushes space away from itself and all the galaxies in space away from each other. And so it has had an effect of accelerating the expansion of our universe over the last roughly 5 billion years. And we want to understand why it's doing that and what it's going to do to us in the future.
So, okay, so you're telling me that dark energy is expanding the universe and dark matter is sort of pulling matter together. That sounds kind of contradictory to each other.
Yeah, exactly. Dark matter, just like regular matter, is an attractive force. So it interacts via gravity by pulling things together.
Now, when the universe was very, very young, dark energy was relatively insignificant, and dark matter was more important. So the universe was expanding after the Big Bang, and the dark matter's gravity pulled it back in so that it was expanding slower and slower. That worked for about 8 billion years or so, and eventually dark energy became more important and more dominant and started to accelerate the universe again. And so the universe's expansion has been speeding up as it goes.
So dark energy is in the lead.
Well, it is for right now, but what we don't know is whether dark energy continues in the lead or whether it changes. We believe that the simplest explanation of dark energy is something that is constant everywhere in space and at all times, and that as the universe gets bigger, there's more dark energy in the universe that has a constant density. But we could be seeing an effect that actually is different with space and time. And so it could be that it is evolving and the universe might accelerate even more, or it might accelerate less. We have to look back in time to understand what has happened so that we know what will happen.
It's all so confusing. So let's move on to our Ask NASA segment, where we get to answer questions sent in by you at home. And remember, if you do want your questions answered by Regina or Dominic, just write them on social media using the hashtag AskNASA. Okay, so let's go here. Safi Khan on Twitter asks, are supermassive black holes able to vanish whole galaxies? Oh, you know what? Let's move on to a different question. I think that's for our JPL friends.
Okay.
Elizabeth on Twitter wants to know what will happen to the future of the universe in regards to dark energy and dark matter. That's a good question. I'm concerned.
That's a great question. And to be honest, I wish we knew the answer. That's one of the reasons why we're launching new telescopes to try to understand what's going to happen in the future of the universe.
That's true. We don't know what's going to happen, but we can say that we know which kinds of scenarios are possible. If dark matter ends up being the dominant component of the universe, then that acceleration I spoke of will reverse, and eventually the universe will come back. If it is perfectly in balance between dark energy and dark matter, then the universe expands forever, but it expands more and more slowly as the universe ages. On the other hand, if dark energy is the part that wins, and if it is accelerating the universe faster and faster with time, then eventually it tears apart the universe. It tears apart the galaxies, and then the solar systems, and then the planets, all the way down to the atoms until it rips apart space itself. We have a great name for it. Astronomers call this the Big Rip. And then if it's in the other direction where it goes the other way, it's the Big Crunch, where everything nestles back down into an individual singularity, which is the end of time.
Ah, so lose-lose.
But don't worry, this won't happen for tens of billions of years. You can binge watch all the things you need to before then.
I'll be sure to put that on my captain log tonight. Okay, so Jesse wants to know on Facebook, if the universe is expanding, what is it expanding into? What's on the other side of that bubble?
Well, this is the question that we love to get. And it's good that Jesse asked that because it gives us an opportunity to try to answer something that is really very difficult to conceptualize. So I would suggest starting out by saying the universe isn't expanding into anything. It's actually an expansion of space. As space expands, it's pushing away from itself, but it's everywhere. Every part of space is moving apart.
So I want to know, what we know some stuff about dark matter and dark energy. How do we plan to learn more in the future? What's in the works?
Now that's a great question. So one of the big questions that we try to answer is how do we understand these questions that we know exist, but we don't quite have all the answers yet for? And that's by developing new telescopes and ways of studying them. And so I, for example, work on future gamma ray missions to try to look for evidence of dark matter annihilation in the universe. And that's one way that we're trying to understand what exactly dark matter is.
And of course, Regina, you worked on Fermi, which is one of the prime tools that we have right now for measuring dark matter.
Absolutely.
And one of the tools that we have right now for measuring dark energy is the Hubble Space Telescope. But I work on a mission called WFIRST, which is planned on taking it a step further, something that can make pictures of the universe 100 times faster to 1,000 times faster than Hubble, so that we can study huge volumes of space to look for the effects of dark matter as it pulls galaxies together and dark energy as it pushes everything apart. That's scheduled to launch in the middle of the next decade and will provide us a lot of the data that we need to answer these questions.
We have a lot to look forward to.
Yeah.
All right, back to your Ask NASA questions. Okay, so Bonnie Walker on Facebook asks, how can you tell dark matter or energy from light? An interesting question.
Yeah, that is a great question. So light is one of the fundamental forces of the universe. And the way that we see things is because they interact with light. And so dark matter, somewhat uniquely, doesn't interact with light. At least that's why we can't see it. And so the only way that we can tell that dark matter is there is by looking at how it affects things gravitationally. And so when we look at a galaxy, we can see that there's some matter there, but we can't actually see the matter itself like we would with our eyes or with a telescope. And so that's how we know there's something there. We just can't see it. And that's how we know it just doesn't interact with light, at least not in a way that we understand.
So interesting.
Yeah.
Well, Regina, Dominic, I'm afraid we've come to the end of our time here. I want to thank you both so much for joining us today.
Well, thank you, Scott.
This has been quite an enlightening conversation.
Yeah, thank you, Scott. This has been fun.
It's also been a terrifying conversation. If you at home want to learn more about dark matter and dark energy, Google it. Or just go to nasa.gov and search some of the spooky science that's available there for you. For our next segment, we're going to be traveling back across the continent to NASA's Jet Propulsion Laboratory. NASA scientist Morgan Cable is going to introduce us to some of the creepy sounds we've captured around planets in our own solar system. My good friend Thalia is there with Morgan. Thalia, off to you. Take it away.
So I am back here with Dr. Morgan Cable, NASA scientist who worked on the Cassini mission. So Morgan, let's talk a little bit about the spooky sounds that exist in our solar system. I understand that some of our spacecraft have recorded some of those spooky sounds, and we can possibly hear some today.
That is exactly right. Yeah, so I was lucky enough to be part of the Cassini mission, which was in the Saturn system for around 13 years, studying Saturn, its moons and rings. And in addition to some beautiful images, we also collected some pretty eerie sounds from the Saturn system.
Wonderful. So will we get to hear any today?
Yes, we will. I think we have 2 different sounds that we're going to be listening to today.
All right, why don't we listen to the first one? My goodness, that was a terrifying sound. Can you tell us a little bit about what we heard?
That was crazy, huh? Well, so you might have heard what sounded like a screaming initially. So you know how they say that in space there's no sound and no one can hear you scream? Cassini could. So there's a screaming sound and then also this whooping sound. So let's talk about how both of these form. So this happened when Cassini was near Saturn, and this was during a time when Saturn's aurora was really active. So actually all of the gas giants, any planet with an atmosphere can have an aurora. Auroras form from, it actually starts in the sun. The sun, in addition to generating lots of light, also spews out all sorts of charged particles in what's called the solar wind. And when those particles come and interact with gases in the atmosphere of Earth or Saturn, some of those gases can get excited and glow. Now, for Earth's case, it's usually oxygen that glows, and it causes beautiful green aurora that you may see in the northern regions of our planet. Well, on Saturn, the gas is actually hydrogen, and so it ends up being a red color instead. And during this time, during this aurora, Saturn is also very active in terms of its radio emissions, and that's what we're hearing. So if you were listening, you wouldn't be able to hear anything. We actually had to shift the sound in frequency in order for us to be able to hear it with our own ears. But Saturn's ears, its electronic ears, were able to pick it up. And what you're hearing is some of these electrons that come in, they get trapped by Saturn's giant, strong magnetic field. If they move along those magnetic field lines, then they form that sort of hissing, screaming sound that you were hearing.
Yeah.
But some of those electrons are actually moving a little bit sideways, and they kind of get kicked out of Saturn and spewed back out into space, and that's that sort of whooping sound that you heard.
Very interesting. So do our own auroras make any sound?
They do, although you can't hear it from Earth. You actually have to be out deep in space to be able to listen to our own aurora. It's called auroral kilometric radiation. It happens at about 50 to 500 kilohertz for any engineers out there.
Awesome. So why don't we go ahead and hear the next sound that you have for us?
Okay.
Wow, so why don't you tell us what we heard in that sound? That one sounded really crazy.
Yeah, this one is kind of creepy and a little bit sad to me because this happened about 2 weeks before Cassini's final grand finale plunge into Saturn. So this happened when Cassini was going by one of Saturn's moons, Enceladus. It turns out that Saturn's magnetic field is so big that a lot of the moons of Saturn's system actually fit inside it, and Enceladus is one of those. Now, Enceladus is one of my favorite places. It's got a liquid water ocean, and it's spewing out some of those molecules into space via this plume. Now, when these molecules get into space, they can interact with things like the solar wind. And sometimes when some of those molecules get hit by a proton or an electron, they'll pick up a charge and become what we call ions. Now, when that happens, now Saturn's giant magnetic field can kind of grab onto them and sort of pull them in like a tractor beam and pull them closer to Saturn. And when that happens around Enceladus, it forms this thing that scientists call a flux tube. And what you were hearing in that sound is Cassini actually flying through that flux tube. So that's why you could hear the sound go up and then go down.
Very spooky. So can you tell us a little bit about your costume today?
My costume, some fellow humans informed me that my skin suit was actually quite convincing. Is it slipping? Does it look okay?
You can probably adjust it and make it look a little better.
Okay.
Yeah.
Don't tell anyone.
I won't. All right, thank you guys so much for joining Morgan and I. We will be heading back to the studio with Scott. Thank you guys so much.
Thank you, Morgan and Thalia. Well, I'll be sleeping with the lights on tonight. If you or a loved one want to hear more creepy space sounds, and who doesn't, go to go.nasa.gov/spooky space sounds. You could even play them during your Halloween soiree this evening. Okay, before we say farewell, let's go and see which photo is in the lead for the scariest image in our universe contest. Just to recap, your options were the Skull asteroid, the Witchhead Nebula, a coffin-shaped iceberg, and the spicy jack-o'-lantern sun. And so far in the lead is the jack-o'-lantern sun. But the polls have not closed just yet. So if you haven't voted, you have the opportunity to change the course of history. This is arguably the most important thing you'll do today. I love the democratic process. And don't forget to send us those photos of you in your space and science-themed costumes using the hashtag #NasaCostume. We want to see them all. That is unfortunately all the time we have for you today. It has been a horrifying pleasure exploring our galaxy of horrors with you, and I hope that each and every one of you have a perfectly terrifying Halloween. Season's greetings!